Today we're going to be solving the problem, a merchant wishes to mix tea worth $8 per pound with a tea worth $4 per pound to get an 80-pound mixture worth $5 per pound. How many pounds of each type of tea should be used? So for this problem, we know that there's some quantity of $8 per pound tea that I'm going to mix with some quantity of $4 per pound tea to get an 80-pound mixture that's worth $5 per pound. So we have to figure out what are the unknowns. So the two questions we want to answer is how many pounds of $8 per pound tea and how many pounds of $4 per pound tea. These are the two questions that we need to answer. In order to answer this, we must assign variables to the two unknowns. So here we'll show that the two unknowns is the number of pounds of $8 per pound tea, which we'll represent with the letter X, and the number of pounds of $4 per pound tea, which we will represent with the letter Y. Now we'll need to set up an equation to solve this problem. Because there's two variables, we're going to need two equations. Now, we know that we're going to mix X amounts of $8 per pound tea with Y amounts of $4 per pound tea. So when they're added together, we know that they will get a mixture that is 80 pounds and worth $5 per pound. So we're going to do this with 8x plus 4y equals 5 times 80. And I'll label this. 8 is going to be the dollar amount per pound. The x is the amount in pounds. The 4 is also the dollar amount per pound, and the y is the amount in pounds. The 5 is also the amount per pound, and the 80 is the amount in pounds as well. So we're going to get a mixture that is 8 pounds with the X amount and then 4 pounds with the Y amount, that is the unknown, and it will equal the 80 pounds that is worth $5 per pound. So we will get a mixture that's 5 times 80. So that's our first equation. And like I said, since there's two variables, there's going to be two equations. So we have to ask, what else are we told? So we have an equation that relates to weight. So if we take the X, which is the amount of pounds of $8 per pound tea, and we add that to the Y, which is the amount of pounds of $4 per pound tea, we know this will be equal to 80. Because if we take this unknown amount of tea plus this amount of unknown pounds, we're going to get 80. So that's our second equation. So now that we have two equations and two unknowns, we can now solve for both X and Y. So we can use the substitution method. So we're going to take the first equation, which is 8x plus 4y equals 5 times 80. And then we're going to take the second equation, and we'll just make it equal to y, so we'll just subtract x from both sides. So it'll be y equals negative x plus 80, and that will be our second equation over here. So y equals negative x plus 80. And now we'll plug in for y in equation 1. So we'll just put 8x plus 4 negative x plus 80 equals 5 times 80, which is 400. And we'll just solve this for the x. So we'll do 8x, and then we'll distribute the 4. So negative 4x plus 320, which is equal to 400. And then we'll simplify, so 4x, and then we'll subtract 320 from both sides. So we'll set that equal to 80. And we'll divide both sides by 4, so we get x equals 20. So now we get x equals 20, which is our solution for x, And now we get to go back to our equation and plug 20 in for x, so we get our equation for y. We'll plug this into the original x plus y equals 80 weight equation. So we'll do 20 plus y equals 80. And then we'll subtract 20 from both sides and we get y equals 60. And so for our final solution, we get that x is equal to 20 and y is equal to 60. And those are our two solutions. So we know that our solutions are now x equals 20 and y equals 60. But now we have to ask ourselves, what does this mean as far as the solution? So if we go back to our two questions that we're trying to solve, how many pounds of $8 per pound tea, we know that we represented this with the variable x. So we know that the merchant used 20 pounds of $8 per pound tea because x is equal to 20. So we can put 20 pounds. And then in the question, how many pounds of $4 per pound tea, we know that we represented this with the variable y. So we know that the merchant used 60 pounds of $4 per pound tea. So now that we know that the merchant uses 20 pounds of $8 per pound tea and 60 pounds of $4 per pound tea, we might now want to check this to make sure that it makes sense in regards to our original problem. So to check to see if we're right, we could simply make two equations to double check. The first one we would do is we would take the number of pounds from our solution of $8 per pound tea, which is 20, and we will multiply that by 8, and then we'll add that to the amount of pounds of $4 per pound tea, which is 60, and we'll multiply that by the value per pound, which is 4, and we should get a mixture that is worth $5 per pound. So if we get 80 times 5, and if we do the math, we get 160 plus 240 equals 400, and 400 equals 400. So we know that that checks out. So the next equation we'll want to do is, we're also told that the weight of the $8 per pound tea, which is 20, plus the weight of the $4 per pound tea, which is 60, so we can take 20, we'll add that to 60, and we know from the original problem that we should get 80, and if we do simple math, we know that 80 is equal to 80, which is also a true statement, so we know that our solution, x equals 20 and y equals 60, is correct. So as you know, our problem is a merchant wishes to mix tea worth $8 per pound with tea worth $4 per pound to get an 80-pound mixture worth $5 per pound. How many pounds of each type of tea should be used? Now, we already solved this equation with algebra and using equations to solve for the variables, but a second way that we can solve this problem is with a data table. Since we're trying to find out how many pounds of $8 per pound tea, we start off with a column of $8 per pound tea, and we're also trying to find how many pounds of $4 per pound tea, so we start out with $4 per pound, and then we have a column for total pound mixture, a column for total price, and a column for price per pound. Now, since we know that the most that the tea mixture can be is 80, we go 80, 70, 60, 50, 40, 30, 20, 10, all the way to 0, and the same thing with 4, but with 0 all the way to 80. Now, the pound mixture is always going to have to equal 80, so all the way down is all going to be 80. So the next column is the total price. This can be found by taking the 80 times the 8, and then you add that to the 0 times the 4. So in this case, you'd get 80 times 8, which is 640, plus the 0 times 4, which is 0, and you get 640. Similarly, down here, if you take the 20 and you multiply it by the 8, and then you add it to the 60 multiplied by the 4, you get 160 plus 240, which equals 400. The final column is the price per pound. This can simply be found if you take the total price, which in the first row is 640, and you divide it by the total pound mixture, which is always going to be 80, which gets $8 per pound. Similarly, down here, if you take 400 total price and you divide it by the total pound mixture of 80, you get $5 per pound. So if you look back at our original problem, you know that we're trying to find how many pounds of each type of tea should be used, when we're trying to get an 80-pound mixture worth $5 per pound. So if you look at our data table, you can see I have highlighted our solution. You can see here that when it's $5 per pound, the $8 per pound tea is going to be 20, and the $4 per pound tea is going to be 60. So you know that your X is going to equal 20, and your Y is going to equal 60, which shows, once again, that 20 pounds of $8 per pound tea is going to be used by the merchant, and 60 pounds of the $4 per pound tea is going to be used for the 80-pound mixture. So once again, we have the original problem. A merchant wishes to mix tea worth $8 per pound with tea worth $4 per pound to get an 80-pound mixture worth $5 per pound. How many pounds of each type of tea should be used? Now, we've already solved this with algebra and equations, and we've solved it with the data table. Now we can use the data table from the last part to graph this to find the solution once again. So as you can see, we can use two graphs since there's two unknowns that we're trying to find, which are how many pounds of $8 per pound tea and how many pounds of $4 per pound tea. So in this graph you can see that I have $8 per pound tea as the x-axis and the price per pound as the y-axis, because we have to find how much tea should we use to get a mixture worth $5 per pound. So all you have to do for this one is go to the $5 per pound, and you go across, and then you go down to the x-axis, and you see that you'll need 20 pounds of the $8 per pound tea. Similarly, with the $4 per pound tea, we have the $4 per pound tea as the x-axis, with the y-axis is price per pound once again, and same thing, you go to the 5, and you go all the way across, and then you go down to the x-axis, and you see that you'll need 60 pounds of the $4 per pound tea, and if you go back, you can see that these are our two solutions, that the merchant will need 20 pounds of $8 per pound tea, and 60 pounds of $4 per pound tea.